Okay, so to know whether a linear equation is also a direct variation, you solve for y. If there's no y-intercept, if the y-intercept is 0, it is. Right? That was not. That one was because it had didn't have a constant term. So you solve, and the constant of variation is -2. The constant of variation 4/5. Okay, graph. Right? If we're going to graph a direct variation, in the end, it's just a linear equation in slope-intercept form. Right? We have steps for this. What are the steps to graph when you have an equation which is in slope-intercept form? Subject of our next quiz. First, you graph the y-intercept. But what's the y-intercept? Always 0. So when you graph a direct variation, it's actually, you're going to put the origin as your first point, always. And then use the slope, just like you would, right? So here we go. So the first one, there's one point is at the origin, and now how am I going to use the slope of 2/3 to find another point on the line? Up to right 3, right? So up to right 3, there. There's 2 points, draw a line. Right, again, this is a +0. That's why it's a direct variation. So the first point goes at the origin. Okay, if it has a slope of -3, how do I use the slope of -3 to find the other point? Say again? Okay, we need something in the denominator. Turn it into a fraction so you've got some left and right there. So that should be, what is the -3 telling you to do? Down 3, right 1. Okay, and close enough. Or you could have done 3 over -1. What are those directions? Up 3 and left 1. So that would have been up 3, left 1. It's still the same line. Doesn't matter. So graphing a direct variation is really just practicing graphing a linear equation in slope-intercept form. So graph that one. So first point, graph the y-intercept. Second, use the slope. What is the slope? Is 2/1. So we're going to go up 2, right 1. Up 2, right 1. Okay, too easy. All right, so here we've got a graph of a direct variation, and we are to write the direct variation equation. Well, you know, we have y equals kx is the direct variation. We have to fill in for k. And we just said k is the slope. So can we look at that graph and tell what is the slope of the line? Can you tell? Is it positive or negative? It's a negative sloped line, right? So let's see. It's got one point at the origin because it's a direct variation, and there's another point, right? How would you go from here to here? You would go up to left 1. So what's the slope? 2/-1? Or you could go down to right 1. So what's the slope? -2. So from the graph, we could tell that the slope is -2. Okay. And okay, now it says find the value of y when x equals 30. How are we going to do that? Given that this is the equation of our direct variation, how will we find y when x equals 30? substitute, put in a 30 for x. And you get negative 60. What happened there? Oh, I think I did this once before. There we go. Okay, this is your U try. This one they didn't give you a graph, but they told you it's a direct variation and it goes through the 0.46. So graph that and see if you could tell what the slope is. Find y when x equals 24. You doing it? Did you already do it? What is it? Come on. Stop responding. Okay. Oh, come on. This thing is just causing me so much trouble. I don't believe this. Okay. I guess I can't do this anymore. Try one more time. 24 equals 36. I would like to finish this if I could. Okay, now if you have a table of values, then wish I had more than just this kind of problem, but this is something we should do. It says explain why C varies directly with S. Well, let's see. Here's a column for C. This is like our Y values. Here's a column for S. That's like our X values. So they're saying this is a direct variation, which means it should be that C equals a constant of variation times S. Well, if that's true, if I divide both of those by S, I get that the K equals C over S. I mean, it doesn't mean that C is always the same or S is always the same. But what should be true is if you divide C by S, it's always the same. So you can do that in this problem here. In every one of these here, divide this number by that number. See what you get. So every time, what do you get? 0.99. So the constant of variation is 0.99. So we can use that to update this. This is C equals 0.99S. So what does that tell us? The cost in dollars equals 0.99 times the number of songs. So how much does each song cost? If the total cost equals 0.99 times the number of songs, then each song costs 0.99, 99 cents. Does that sound reasonable? How much does it cost now? Yeah, I mean, I see, it seems as it's definitely more than $1 now, but not much. And it hasn't been that long ago that you could actually get for 99 cents. Considering this book was written in 2007. I think if you remember, well, you guys don't remember, you're too young. But, before you could buy a song for 99 cents or something like that, there was Napster. And Napster was a place where everybody would just like put all of their own music on their computers and then allow other people to reach into their computers and take it for free. There wasn't any option to just like buy one song because you wanted one song. So people were using Napster to just share music, and they were upsetting the record companies a lot because they're saying, look, if you want the song, buy the album. People are saying, I don't want to buy the album, I just want this one song. And so, yeah, that's what you did before you could actually buy one song because you wanted one song. I mean, some people, go ahead. Well, I know in the early 2000s we were doing that. I mean, I don't think Napster exists anymore, but I think they tried to adapt. When iTunes came along with a way to like sell individual songs, then Napster kind of went away because you didn't need it anymore. But understand, like Napster didn't host any songs. They didn't have any songs. All they were was a piece of software people could use to go to somebody else's computer and grab music. That's called peer-to-peer. And they weren't actually giving you anything at all. So they would say, look, we're not giving anybody any free music. I mean, they're just going to somebody else. Of course, they had to, go to court over that many, many, many times. But then since they started selling, I mean, I could tell you I probably downloaded maybe in the low hundreds on Napster when it was new. It was really the only way you could do it. And then once they came along with iTunes and that, okay, I don't do that anymore because I do have an option. I mean, most of us aren't going to buy a whole album if we just saw, it's like some album that's 40 years old. Are you going to buy the whole album just because you want to hear that one song you remember? No, you're not going to do that. So things have changed. But so this is not that long after they started those, iTunes selling songs and things like that. And it was 99 cents or thereabouts. And now it's just a little more than that. That's pretty good. Okay, so then we're going to move on from direct variation, which we understand pretty well. And we're going to go back to, this was the function notation that we did before, because we had questions on our last test about this, and we didn't do very well on them, and we do need to be straight on this. Evaluate a function when x equals -2, 0, and 3. Right, for the number 7, I'm going to do the number 7. Okay, if it says evaluate when x equals -2, that means find m of -2. So how do you do that? If this is the m function, how do I find m of -2? You substitute x equals -2. So in this here, I'm going to say -6.5 times -2. So the answer is 13. So m of -2 just means plug in -2 for x and simplify the right. Okay, don't worry about the m of -2 anymore, right? Just simplify what's on the right-hand side. Okay, how about if I have to find, it says evaluate when x equals 0, that means find m of 0. And again, what are we going to do? Substitute 6.5 times 0. Let me start counting on my fingers and toes. That would be 0. Okay, find m of 3, which means substitute. What is -6.5 times 3? -19.5. Okay, you guys do the number 8 for here, you try. Did I get all those right? So we understand the concept. If you have to evaluate a function for a value, that means you plug in that value on the right and simplify the right? Don't worry about this side anymore. It's done. Brandon, staying awake? Okay. So when I find f of 3 means put a 3 there and just simplify this part. Okay, let's try one more. I'm going to do the one on the left. You can do the one on the right. Remember, you have a calculator for fractions if it's an issue. So I did the one on the left. I did some of the, if you get to this point, if you're not just putting it in your calculator, right? How did I figure out -4 fifths plus 3? What do you need in order to add fractions? Common denominator, right? So in my mind, I just said, well, how many fifths is 3? 15. 15 over 5 is 3. So I said -4 plus 15 is 11. Or this one down here, 6 fifths plus 3. Again, 3 is 15 fifths. So 15 fifths plus 6 fifths is 21 fifths. Now you could, in your calculator, right, you could put in this, right, just like that. If you did, you probably got 2.2. Did you do it that way? Get 2.2? Did you enter it as a fraction using the fraction? Because that would have kept it as a fraction. But if you didn't, if you just put it in the calculator, -4 / 5 plus 3, it'd probably give you 2.2. You could turn it back into a fraction by doing the math enter. Okay, how about, what'd you get on the first one on the right? You said 8. Let's see, -2, that'd be 6 plus. Are you sure? Yeah, that's correct. So it should have been d of -2 equals -3/2 times -2 plus 5 equals 8. How about d of 0? That's the easy one. -3/2 times 0. So the whole first term is 0, which is 5. And d of 3 is -3/2 times 3 plus 5, which is -9/2. And then how many halves is 5? 10, right? 5 is 10 halves, 10 over 2. So finding common denominator, I get 1/2. Did we get all those? Yeah. Did I make a mistake? Okay. Did you get -9/2 for that term? Okay. That's good. So the other problem, and this was the thing that we didn't do well at all, right? The worst of it. It's the opposite. They're not asking us to evaluate for a particular value of x. They're saying, substitute in this case, the m of x equals -2, and then find the x value, right? So in this case, it'll look like this. And this is a little bit just, worded, the way they've worded this is kind of odd, but when they say the given value is this thing right there. It's that thing right there. So they're saying put that value in the place of mx. Don't put it in the place of the x. Substitute the whole mx so that it looks like -2 equals 9x minus 5. Now that's a simple equation to solve, right? So then solve that. Add 5. 3 equals 9x. Divide by 9. X equals 3 over 9, or 1/3. So try to do the same thing on the number 19. Replace the n of x with that, and then solve that equation which is left. Again, so you start by put a -6 in the place. There's no more n of x. It just says -6. Did we get that far? Right, we took that first step. Now solve for x. Right, this would be a two-step equation in our solving equations chapter. Add 21. 15 equals -2x. Divide by -2. Divide by -2. So 15 over -2 equals x. Or what else? What else do you call that? Did anybody turn it into a decimal? And you got -7.5, right? Okay, I think these are the last two. So same thing, right? Find the value of x so that the function equals that number. So in this case, I'm going to put the -3 here. -3 equals -12x minus 36. Add 36. $33 equals -12x. Divide by -12. X equals, what's a common factor between 33 and 12? 3. So I can factor out a 3. That would leave an 11 in the numerator, and it'll leave a 4 in the denominator, and the whole thing's got to be negative. Somewhere in there, there's a negative. Try the number 21. What is this one going to be? -4, add 28. X equals what? 7 over 2, right? Divide out of 4, which is 3.5. Okay, so we'll get a little more practice at that too. Okay, the average price of a movie ticket in the United States from 1980 to 2000 can be modeled by the function f of x equals 0.1x plus 2.75, where x is the number of years since 1980. Okay, graph the function, identify domain and range. Okay, so this is a linear function, but we're going to use this. This is going to be our x, and this is going to be our y, but y equals f of x. Okay, what is going to be the domain? Is it possible that the domain is 0, is less than 0? It says the years since 1980. So what's going to be the first number in our domain? 1980s, right? That's the 0 year is 1980. What year then is 2000? 20 years since 1980 would make that a 20. And if we're going to graph this, like we did in the previous, which honestly we said, we know now this is a straight line, and we know that we only need 2 points. So you could practically just use those 2 points. We used 3 in the last unit. I'll put in a 10 just for fun. Okay, now we need to use this function and evaluate. Okay, if I put in 0, what do I get? 2.75, right? The first term is nothing, which tells you that in 1980, what was the cost of going to the movie? $2.75. Okay, what if you put in a 10 for x? Right, that means find f of 10. 0.10 times 10 plus 2.75. Now how much does it cost? 3.75? So now and what year is this? 1990. Okay. Okay, now let's do the f of 20. 0.1 times 20 plus 2.75, which is $4.75. Okay, $4.75. So if I graph those 3 points, I've got 0 is here. I'm going to make these are every 2. So 1, 2, 3, 4, 5. There's 10, and there's 20. And then this will go 1, 2, 3, 4, 5. There's 5. 0, 2.75 is about right there. 10, 3.75, which is about right there. And 24.75, which is about right there. Okay, and graph it. That's a line goes like that. Okay, we know the domain now. The domain is these x values here. How would you describe those x values? Use a 3-part inequality to describe that. Well, maybe with a 3-part inequality, we won't say greater than 0. You say 0 is less than, right, the x value. So say it like this. The domain is 0 is less than or equal to x is less than or equal to 20. Those are all the x values on our graph. Okay, what are all the y values in our graph? It's kind of hard to look at the graph, but look at the numbers here. What's the least of the y values? What's the greatest of the y values? So how could you write that as a range? Right, I would say 2.75 is less than or equal to y is less than or equal to 4.75. Right, that's the lowest and the greatest, so it's in between those two. Okay, when it says find the value of x so that f of x equals 4.55, what are we supposed to do? Find x so that f of x equals 4.55. Do they want us to plug in 4.55 for x? What do they want us to do? Substitute f of x equals 4.55. So do that. Let me do it. Insert. 4.55 equals 0.10x plus 2.75. Solve. Right, that's what they're saying. Replace the f of x with 4.55. Solve for x. Subtract 2.75. And what is that? 1.8? 1.8 equals 0.10x. Divide by 0.10. X equals 18. Okay, what does that mean? Remember, what did x represent in this problem? X is the number of years since 1980. So what is 18? Come on now. 1980 plus 18? 1998, right? So this means 1998. And what are they telling you that happened in 1998? It cost $4.55. Okay. How much does it cost today?
Like 8, 9, something like that.
8 or 9? Is that it? I rarely go anymore. So there's homework.